start? Okay, sweet. My name is Matthew Desaulniers. I'm a senior electrical engineering student here at Florida Poly, and I interned at Sofwerx over the summer. So to give a little background of Sofwerx, I know some of you are very familiar with Sofwerx back there. The soft in Sofwerx doesn't stand for software, which is always the question I first get when I mention it, but it stands for Special Operations Forces Works. So what they do, they're a nonprofit that was created to kind of mitigate the procurement process that the military and government is constantly dealing with. I'm sure you guys are all familiar with the idea that the government moves really slowly to get anything done. So the purpose of Sofwerx is, let's say someone at SOCOM, which is Special Operations Command at Tampa, or an operator out in the field in Afghanistan, let's say, has an idea and says, oh, I want a Pixel phone, I think that's going to be the thing that makes my life way easier. Well, rather than having to go through this whole 1 to 3 year procurement process, we can just get Sofwerx to next day ship it because they're a separate nonprofit company, and we can kind of just test the product out, go, okay, this will work for you, maybe this won't work for you by communicating with the customer. And then that allows SOCOM to kind of skip some of the, oh, you want a Pixel phone, find 5 other phones, and test all of them out, go through this whole kind of approval process that takes a very long time. This kind of lends itself to Sofwerx being an integrator. A lot of you guys are probably familiar with that term, Lockheed Martin, Boeing, things like that. So they don't just make the product from scratch. If I want to make a plane, I might buy some screens from Samsung, some control systems, and let's say RF systems from L3 Communications, and I'm going to integrate them all together into one thing. So Sofwerx does a lot of that, kind of finding a bunch of different businesses in their own little niches and bringing them together to create a product for an operator. I made some identified learning outcomes in the beginning of this, and it was actually really interesting reading back on them when I was making this presentation, because of how kind of narrow they were. I didn't realize how much I was going to end up doing at Sofwerx. So what I did settle on in the beginning was integration and considerations for integration, which is kind of a clear one. At the time, I knew I was going to be building a quadcopter, so putting a lot of parts together and figuring out how quadcopters work. Time management. This was when I first started working there. I was immediately assigned 2 projects and kind of with not too much oversight on one of the projects, and was told, okay, go out and get it done. And troubleshooting, I'll get into that later. Of course, it was part of pretty much every project, but one predominantly dealt with a lot of troubleshooting. However, I would like to point out that looking back on it, there was a lot more than just these 3. We had a ton of communication, lots of market research, more communication, and then very specifically, although it's still kind of communication, talking to customers and understanding what they want is its own really, really important kind of, I guess, learning outcome in this conversation. And it came up quite a bit, and it'll come back later. So the first project, and as a double E, this was kind of the most relaxing project for me. They were like, hey, we have a car, it's got a battery leakage problem, it just keeps dying, and it's an electric car. So I'm like, okay, cool, I'll just go get a multimeter and start testing her out and see what I can find. This one was pure troubleshooting. I literally went in with the multimeter. I had to be a little cautious, of course, because half of this system is very high voltage, very high current. If you're running a motor on a car that's supposed to be able to go 60 miles an hour and tow 1,000 pounds, you're going to have a lot of current drops. So other than some of the lower voltage parts of the system, I had to rely heavily on documentation. This car was actually purchased as a custom vehicle for Sofwerx. So the idea is we're going to mount a refueling system for helicopters. So helicopters can very rapidly be refueled. You send the car out with a ton of helicopter fuel on it, refuel a helicopter in the field, let's say in an actual grassy field, and then drive the car out and everything's gone. So because it was custom, reading through, once I got hold of some documentation, you could tell it was written very quickly by the engineers who gave it to us, and it was missing a lot of stuff. So the biggest thing in this project, I would say, was understanding the documentation and getting through it and getting to the engineers and going, okay, hey, I read your entire manual. I feel like I understand the electrical system, the mechanical systems. I'm still not understanding why this one specific wire is pulling so much current. It ended up being this switch called a blackout switch, which wasn't really mentioned at all in the hand guide, except for sometimes it would say, hey, the headlights won't work if the blackout switch is off, or this other thing won't work if the blackout switch is off. After a lot of emailing back and forth and troubleshooting, all the blackout switch does is say, hey, let's say there's an enemy nearby, or you have some communication that you need to cut all power to everything, make sure no lights or anything is running, you turn the blackout switch off. That's what it does. It's a blackout. Makes sense now. Yeah. So, however, when it's on, all it's doing, if everything else is off, is running a relay, which pulls about 100 milliamps and will drain a car battery in about 4 days. So all cars have what's called parasitic current draw, but usually they're nowhere near 100 milliamps. So that was kind of the big thing at the end of that. So my solution after like a lot of talking to people was, hey guys, just make sure you don't keep flipping this blackout switch into the on position and you'll be good. One of the most interesting parts of interning at Sofwerx was being able to go to Sofig. This happens in Tampa every summer, and it's Special Operations Forces Industry Conference. This is essentially a trade show for Special Forces, so you can imagine there's a lot of big companies there showing a ton of different Special Forces stuff. There's like companies literally devoted to connectors for different cables. Of course, there's going to be like missile vendors there, armored vehicle, like crew carriers, satellite vendors. You have a little bit of everything and some really weird stuff, like this guy was selling headphones that sent a current into your head, and he said it was supposed to make people train and learn faster. So a lot of interesting stuff there. It was a really good opportunity for networking because as a student, I can just walk around, and as a double E, I was like, oh, okay. Satellite vendor, talk to him for 5 minutes and go, hey, do you guys take new grads, or like how does that work for your company? And a lot of times after making a little friends with them, they would say, oh yeah, here's my card, call me when you get out of school. So very good networking opportunity. And at the end of it, they have a collaborative between multiple country special forces groups demonstration where they kidnap the mayor of Tampa, Bob Buckhorn. He is shooting a machine gun in downtown Tampa. And they do a lot of people dropping out of helicopters, boats dropping out of helicopters, and parachuting out of planes, and kind of like do a little maneuver where they get on this yacht and rescue the mayor, and he shoots off a machine gun in downtown Tampa. So entertaining, if nothing else. The other project that I was working in parallel with the TomCar electrical issue project was the X-Fold Smart Rail. This was part of a Thunder Drone initiative that SOCOM asked Sofwerx to start. The idea is drones are the new shiny thing in the military, and SOCOM wants a lot of new shiny drones to look at. So one of these projects dealt with getting a ballistics optical system that normally you would put on a rifle or a gun like that. What it does is you click, well, first you set like all your wind settings, humidity, and a lot of other ballistics related values. And then you say, okay, this is the thing I want to shoot at. Let's say you're aiming at a house or something, or a car. It'll do some object recognition on the car and say, okay, I think I know generally what you're looking at, and it will not allow you to fire until you're over the target, whether that means aiming actually above it because of the ballistics that have programmed in it, or actually aiming at it. In our case, we set it to don't fire unless you're over the target, and then automatically fire. So of course we're in a lab, so we just have a laser that just turns on when it fires. And my half of that project was getting this drone built. I've never built a drone before this drone, so it was really interesting to kind of on my first day be given this kit for a drone and go, hey, make it work. We have this whole project that is kind of riding on this drone, literally riding on the drone. So we did end up getting it working in the end. However, the vibrations of the motors in the drone were too much for the software and the ballistics camera to deal with, so we couldn't ever really get it to lock and fire. once it was flying until we put it on another bigger, smoother drone, and it worked. So that's something looking forward. We probably would have had to look more into stability of motors, kind of like the smaller things in a project. This was, and actually still is, probably the longer and most intense project. I worked at Sofwerx K9 ISR. So that's K9 as in dog and ISR as in intelligence, surveillance, and reconnaissance. This was what's called a warfighter nomination for Sofwerx. So these guys at a first Special Forces group in Utah said, hey, we train these canines and it would be really helpful if we could have a system that worked such that I could have my dog remotely doing things, streaming video off of its head, and I give commands out of a speaker on its collar. So rather than following it around, I could send it into a house or something like that. It could look around, get upstairs, places a robot cannot go yet, and I could get all my information like that, and then just have it come back in, let's say, a full duration, 15-minute mission for the dog. The problem that they were having first is that once you get into tunnels, caves, things that you would see in Afghanistan mainly, or dense urban areas, you lose radio contact. So one thing was, how do we get radios to work as soon as you cross or turn a corner as the dog? And the second part is that giving a camera to a dog is essentially, you might as well just give a camera to a 7-year-old and just say, hey, go around with this and we're gonna try to get good information off the camera. It's gonna be really hard. And if you don't have an immediate response time to tell the dog something, then the dog's just gonna be, let's say you say stop and it takes 3 seconds for the dog to hear it, then in dog time that's like 50 feet. So it's gonna be way past the thing or in a totally different room by the time it hears you. So a big issue they were having was video latency. The latency was anywhere between 3 and 10 seconds behind the dog, which is unusable at that point. What we ended up doing for them, there's actually a demo on the 27th at Dugway Proving Grounds in Utah. We're going to be placing radio nodes at specific spots because we just didn't have enough time to set up a radio repeater automated dropping system off the dog vest. And for the video latency, we went through a ton of tests, just buying a bunch of analog, USB, Ethernet cameras, going, okay, well, if it has to go through a radio, which is this in our kind of block diagram here, then it has to be, it's going to have to get compressed. If it's analog and you want to send it out, it's got to get compressed. So we found the quickest method was to just purchase an encoder. We ended up just getting a Panasonic encoder. These things were kind of more popular around 2004, 2008, when USB and IP cameras were kind of like being phased in, but people still had a lot of analog cameras, so you just buy a separate encoder. So we did that. It encodes it within about 150 milliseconds, and then you send it through the camera, and then the camera adds a little bit more latency, so in the end our latency ended up being around 590 milliseconds as kind of a nominal value for performance. Our lowest was actually 190 through the radio, adjusting some of the H.264 compression that we were using. However, when you did that, it was very choppy, and once again, if you give it to a 7-year-old and they just start banging it around, you're not going to be able to see anything at all. So this is kind of the most of the setup we have. This was a camera map. This is just kind of an enclosure to set on the dog's head. We were actually able, in the end, to put our whole system in something about the size of a pencil pouch, which is really nice for putting on a dog. And we have a block diagram here, which is just a battery, power switch, the actual radio, our video encoder and compressor, and the camera. All this is off of the user guide that we actually finished yesterday. The biggest things in this project were, really the biggest thing for sure, it was communicating with the customer. Talking to operators is very different from talking to engineers. I remember a few conversations we'd have where we would go, okay, well, what kind of resolution do you want? And they go, I want something, and give us a qualitative answer, let's say, I want to be able to see a room. But to an engineer, you go, okay, well, I can see a room in many different resolutions. So we would always go back and forth and go, well, how many frames per second? And eventually we got to this point where it's not useful to ask these quantitative questions because sometimes the person just doesn't know what that means. They just know what they want. So you have to go through this 20 question style game where like, is it okay if it's bigger than a microwave, smaller than a loaf of bread? Everyone understands that, and then you kind of use your judgment with these qualitative values you obtain. What we actually ended up using for the video resolution was, the guy said, I want to be able to see a box of Lucky Charms, know it's a box of Lucky Charms, but I don't need to read the nutrition facts on the box. And that is super simple, everyone gets it, and literally we were just using a box for testing in the lab, going, okay, can you see that it's a camera on the front? Yeah, okay, you don't need to read like the FCC, regulations of communication on the back of the camera. And then complexity was another one. We actually had another build before this that included an encoder with a power over Ethernet injector. This added 6 electrical interfaces to the design. And the one thing that I was told by every single engineer that I worked with in there, and it's kind of just intuitive, the more points of connection you have in your system, the more likely your system is to break and the harder it's going to be to fix. So as soon as we built the thing in like a laboratory setting, it was okay. As soon as we tried to ruggedize it and put it on a dog vest, it broke. It was extremely hard to figure out exactly what was wrong with it. So we ended up kind of trashing that system and building this one, which works much more smoothly and of course is much smaller. So the last part is kind of a unique experience at Sofwerx. You get to do what's called a pecha kucha. This was a special type of presentation invented by Japanese architects who, for lack of a better term, were tired of death by PowerPoint. You do like 4-hour PowerPoints and you have like 10 people all presenting to you and you have days taken up by this. So what they do is you have 20 slides at 20 seconds per slide. So this amounts to 6 minutes and 40 seconds. They make all the interns do this. It's really interesting trying to format it like that because you're trying to convey this information. You literally have 20 seconds to do it, which by my kind of like off-the-hand calculation when I was doing it, you get about 2.5 sentences per 20 seconds. But one thing that I really was trying to take advantage of was that the audience at Sofwerx is extremely broad. So I had my boss, who was an RF engineer, my supervisor, who was a PhD aerospace engineer, and then I also had the admin team, the marketing team, and the business team. So you have this really broad audience, you can present anything you want to. So of course I was like, all right, I'm gonna try to present something relatively complex to a broad audience because that was the great difficulty in a lot of my projects anyways. So I might as well practice that. So I did my presentation on ring resonators. I know you're familiar with that, and it went pretty well. I think I pushed a little too hard at the end, but I would say the first half of the presentation I mostly did an introduction of physics and vibrations, and a lot of the whole admin team, marketing team seemed to understand it, which I was really, really happy about. And the IT guy at the end said, you almost made resonance sound interesting, which for me, I was like, coming from the IT guy, that sounds like a compliment. So, yeah, so that's about it. Any questions?
You mentioned a couple times that the biggest thing that I guess that surprised you had to deal with was communication.
Right, yeah.
What did you feel prepared for that by your coursework or your experiences here, or if not, what could we do differently?
Yeah, actually, project management was super useful for that. Also with Dr. Or Professor FICA, who's really good. Yeah, that was one thing. I don't think I really understood the whole talking to a customer thing as well. A lot of the like working on a team and communicating, okay, what are you doing, mm-hmm. And also we'll have set deadlines for actually like, okay, we need to talk again in a week so that we're not stepping on each other's toes or redundantly working on different tasks. that was one big thing that was like, oh, okay, I feel pretty prepared doing this. The whole like teamwork thing.
Yeah.
But once I started talking to outside people, and really the customer requirements thing was so big, because we actually had a point where one week we thought what we should be working on right now is dropping radios off a dog and getting an integrated radio system. And then literally the next week when we had our scheduled meeting to talk with them, they said, if you don't have the latency fixed, the whole demo is garbage and nothing's gonna work. Which completely changed our project to where we weren't even gonna work on the other radio stuff, and they were like, if you get latency working for us, that's good enough and it will be a huge success. So that was one of the big communication things of maintain periodic communication that I definitely was prepared for, because as soon as we started the project, it was like, okay, well, when is our meeting time internally, and when is our meeting time externally?
So, it's two-sided, one good part, one expected learning process, sometimes troubling part. Right? The project is interesting, it's funny, I worked on a project like this with the county police department about 12 years, 13 years ago. And, there's value that people just don't fully grasp. And so it's a great project. So that's great. I'm glad you got to be part of that.
Yeah.
And I think you mentioned, in the description, you kind of described that nicely. So the other part is, if you are talking about latency, right? It's a two-part question. Did they describe to you what latency was?
Their latency was the time it takes for a dog to do something and me to see it on my end. So it's going through camera, compression, radio signal, and then in their case it was going into Android software and then them seeing it. So latency for them was the whole system of latency. Whereas for us it was like break it down and see what the actual latency was, if that answers your question.
Not quite. So
This is part of what do you do?
Yeah, and this is understandable, and this is where these things come up. The term latency, right? Did you ask them if they understood what latency implied in this kind of technological framework?
I don't think, not so pointedly, no.
Right. So one thing that's really important, especially in an internship, and you may get this opportunity again, right? You got to practice asking tough questions. If you don't, you're going to have problems for the rest of your life.
Okay, yeah.
And it's an opportunity here because the repercussions are minimal. You can upset your boss, and there's really no problem. I hope everybody understands that. So it's a great opportunity. It's something to keep in the back of your mind and realize that people who sometimes are giving you the assignment may lack the necessary knowledge, awareness, and capabilities to purvey something positive and fruitful.
Okay.
So,
Yeah.
you understand what I'm saying?
That makes sense. Yeah, rather than beating around the bush of like, what exactly is this thing, you could just ask directly.
Exactly.
Okay.
And then the next time you'll learn how to refine it. So when you're working full-time for a job, you can understand, all right, now I can ask this poignant question, not get fired for asking it, because I presented it the right way, because I learned what that means and what it feels like.
Right. Yeah. Okay. This is a direct into question with tact, I guess.
Yeah, or however it needs to be done.
Yeah.
So,
Yeah. Yeah. I see what you're saying.
so good, great, thank you.
Okay.
Which of these was your favorite project to work on?
Probably, I really liked the K9 ISR project, partially just because of how much it covered. We went from market research into building the thing. We had a lot of problems with it. There was a ton of communication that we had to do. And then, like, literally yesterday, I was working there making the user guide for it. So, and all the documentation with some specs for it.
That was the question I had too. You mentioned documentation. In fact, I think everybody mentioned documentation so far today. What level of preparation have we given you in terms of reading, understanding, and writing documentation?
Let's see. I think DLD, a lot of the circuits classes and anything dealing with components has kind of pushed me the most into documentation, just because if you're handed a chip next to spending like, I don't know, a month just putting inputs and outputs and trying to guess your way through it. Reading the documentation is the only way to understand it. And when you have good documentation, it's super convenient, and was really helpful in a lot of those electronics classes. I can't say that I went through too much documentation in many other ones, other than like programming, MATLAB. I've read a bunch of MATLAB documentation, of course. MATLAB also has really good documentation. I think it's one of those things that when it's there, you don't really think of it too much. When you deal with something that's not well documented, you realize how nice, good, like well-written documentation is for a project.
Yeah. I'm asking for selfish breakdown reasons.
Yeah, no, that's fine.
But, to make sure that you're all.
In terms of MATLAB, approach me afterwards as something for you that I think will help you for the long term,
Okay.
because it'll come up again.
Yep, sounds good. I have one other thing that I meant to mention earlier. In terms, I know we were supposed to like connect this to coursework. As I was doing this, I was having trouble thinking of a time where I was like, connecting it to some quantitative, like, the attenuation constant or something like that. However, over the course of my education, many times people would ask, what are we going to use this for? People don't use it, and then the response is, I'm teaching you how to think, not what to think. That definitely came into play quite a bit, especially dealing with radios and RF. At no point did we really bust out any like actual equations for RF stuff. However, because I've had some fundamentals, we could very conveniently talk about what is possible or reason out, okay, why are we getting these weird signals? Why are we not connecting to our radios in this case? Oh, okay, it's probably reflecting off of this big metal beam here, or it's attenuating through these three walls. And just being able to reason things out like that and kind of have an intuition about how a lot of electronics work came in handy constantly throughout that whole process.
Cool. Good. All right, thank you.
Good.
So,
Thank you.